Today we will discuss why do we need functions. In mathematics, we often come across expressions involving the variable x, such as the one shown below. This is algebraic one. The second one is exponential together with logarithmic and so on. Now to manipulate this type of expression, so every time we have to write this whole expression or mention this whole expression. So to avoid writing this long expression again and again, we simply give them names such as f of x, g of x or h of x. These names make mathematical discussions much easier. These named expressions are called functions. In this case, since x is here, so these are functions of x. So the above expression can be written as follows. The first one, we are writing f of x is equal to 5x cube plus 7x square minus 3x plus 8. Second one, since f of x we have used, this name we cannot repeat for the second expression. So here we have given g of x. If there be any third expression, so we'll make use of h of x and so on. Now we'll discuss how functions are generally written. So here we have written f of x is equal to 5x cube plus 7x square minus 3x plus 8. Now why we have written f of x here? Since on the right hand side the expression given is in terms of x, so we have written f then opening bracket x then closing bracket. Similarly for the second case, since here also it is in terms of x, so g of x opening bracket x and closing bracket. We cannot write f of x in both the places because this is one expression, this is a different one. So we follow here one convention to name this. We start the name with small letter or lowercase letter like f, g or h. F here or g or h, so on, to name this function. And we make use of a pair of brackets enclosing a variable such as x in this case to indicate that the expression on the right hand side is in terms of x only. If the right hand side expression is in terms of t, then we'll write f of t here. Inside parenthesis we'll write t. In second case, say for example, the right hand side is in terms of u in place of x. Then here we'll write g of u. So if the expression is written in terms of another variable such as t or u, then we write f of t or f of u or g of t or g of u. Why do we use y in place of fx? Here fx represents this algebraic function. Now if we have to refer this expression at many places, so everywhere we have to write fx, f of x. So it consisted of 4 letters. Instead of writing all 4 letters, we can further simplify it by using single letter y. So this is another variable which is same as fx. Only thing is here only one letter is sufficient. So it has further simplified this expression naming. Now one thing we have to note here. Here in on left hand side there is nothing mentioned like x. So we have to be sure the other hand side is in terms of x or t. But here from we'll be sure that the other hand side is in terms of x. If x is here, if t is here, the other hand side, the expression is in terms of t. That's the benefit of fx. But to simplify, if we know the other hand side is in terms of a particular variable, we can make use of y. Again, when we are plotting a graph in a plane with x-axis and y-axis, the x values goes along x-axis and y value goes along y-axis, giving the nature of this graph or curve. So it becomes more easier to make use of y in place of fx. But both y and fx represents exactly the same thing. Here x can assume different values independently. So x is called independent variable. And for each value of x, after computation of this expression, the result obtained is assigned to y. That value is the value of y. So value of y depends on the different values of x. If x is equal to 1, so we'll put x equal to 1 here and compute it. The corresponding value of this computed result will be assigned to x. Similarly, for x equal to 2, if we put it here, the corresponding value will be assigned to y. So the value of y depends on the value of x. So in this case, the variable y or fx, each of them is called dependent variable. Now functions in terms of u or t. So long we were discussing functions in terms of x only. Now here, since the expression is in terms of u on right hand side, we'll write f of u, function of u. Here independent variable is u. Or further simplifying it, we can write y equal to this whole expression. But we have to be sure. From here we cannot make out whether the expression on the right hand side is in terms of u or not. So it should be clear from the context only. Similarly, we have another function, say in terms of t. Generally, time, when distance versus time function comes, then at that time we make use of this t. So here the independent variable is t, and the function is in terms of t, and it can further be simplified y equal to this. So if we know that the other hand side is t, we can make use of y instead of f of t to simplify. the expression. The above expressions are examples of functions in terms of u or t.